Okay, so question number 1 says, which graph illustrates two variable data? Okay. So we're looking at 3 different graphs here. We're going to address each of them. We need to figure out which of these addresses two variable data. I'm going to quickly take a look at this. Many of you guys would have put B. What was the correct answer? Anyone have it with their stuff?
What one is it? Question B.
So the way we're going to address this is independent and independent variables. We're going to quickly write off C and D. First of all, in question D, there's only one variable. It looks like the idea, though there's no topic on the question, it looks like maybe it's favorite sports or sports people play. There's only one variable there, so we're not dealing with D. C, same idea again, they just have different colors and the number of students. So kids' favorite colors. They've actually given us a title in this one. Okay, so they've given them options of a color. This is not a variable. These are the actual options, and these are what the kids chose. Again, we're only talking about one variable. Height of sunflowers. Okay, we're talking about independent and dependent variables. Does anyone remember where the independent variable goes? What axis? X, that's right. It's going to end up on the x-axis. So this is our independent variable. And what that means is our y should be the dependent variable. So in other words, this must change according to the independent variable. So the independent variable, it looks like here, is height of a flower. Okay? And they've given us the different heights of sunflowers here. None of them seem to be within 0 to 20. And then from 20 to about 55 inches are the options. Now the other variable here, or so-called variable, is the number of flowers. Does the number of flowers that grow depend on the height of the flowers that have already grown? No. Flowers that have already grown in height is not going to be affecting the number of flowers that are going to grow in the future. Okay? Now this one looks very close. It does have numbers on both of them, but this is not two variable data. The number of flowers is just they have walked into some field and they've counted the number of flowers at 20 inches, the number at 30, the number at 40. This is not really a variable. This is just helping us total the number of flowers, like a histogram. Okay? Now B. B looks like it may only be single variable because of our x-axis. What do we think the x-axis is measuring? Because of the time frame we're in right now. What are those numbers? They look like they'd be years, which really wouldn't be an independent variable because the years are going to change no matter what. But they've actually not titled that. We have no idea what it is entailing. Okay? So we're going to go on the assumption here. We have our double numbers here, that these are affecting whatever is being measured over here. Essentially, this was a deduction question. A, C, and D were definitely not two variable data. B was arbitrary. It could have been. Okay? It was the closest one that would have been in this case. Now that I look at this is a tricky question. I should give you guys some kind of title along with this. But because A, C, and D were not, we're looking for question B as our answer. Okay? So question B was the answer to the very first one we did. Wow. The coach of a track team. Okay, so we're reading number 2. Coach of a track team surveyed the team members on how long they slept the night before a race. Each coach constructed these 2 graphs. Okay? Choose the best description of the graph. That's what this one is referring to. It says that graph 1, this is question A. Graph 1 displays information about a possible relationship. So we have hours of sleep, time to run the 100 meters. In the other one, we have hours of sleep and number of runners. Okay? So question 1, graph 1 displays information about a possible relationship. B says graph 2 displays 2 variable data. C says graph 2 displays information about a possible relationship and 2 variable data. And graph 1 displays 1 variable data. Again, we're looking for a deduction. We got to figure out which of these doesn't make sense. So question B, it says that this graph here is two variable data. The number of runners and the hours of sleep. Am I taking two different variables here? In either of these, am I taking two different variables? Are either of these two variable data of these graphs? Number one is two variable data, okay? We're talking about the hours of sleep, which varies depending on the runner, and then how fast they run the 100-meter in. That's another variable. Depending on the person, they may have slept a lot and ran very fast. Maybe they slept only a little and ran very slow, okay? Both of those are changing things. The number of runners is essentially going to stay consistent. You bring your team, say there's 10 people, it's most likely all 10 are going to run. There's really no dependent variable on that. Depending on the hours of sleep, it's not really changing our number of runners in our race. We're bringing 10 guys. 10 guys are showing up. So we know option B doesn't make sense. This is not two variable data, number 2. This is not two variable data. Graph 2 displays information about a possible relationship and two variable data. By deduction, again, we know it's not two variable data, so it cannot be C. Graph 1 displays one variable data. We just talked about how many variables are in graph 1? 2. How fast they run the 100 meters and their hours of sleep. So we know there are two variables in that one, so it cannot be D. A says graph 1 displays information about a possible relationship. It's possible this has to do with a relationship. They're all kind of centered around one area, so it doesn't seem like we have any linear or quadratic or exponential relationship. But the other ones are for sure not, right? A is a possibility. It's possible this does deal with a relationship. So we're looking for answer A in this question. Okay, that's number 2. Question 3. Which pair of variables are likely to have no correlation? Right? No correlation. So there's really no relationship at all between them. Blood pressure and heart disease. Would they have a correlation? Yeah, probably. High blood pressure tends to lead to some type of heart disease and vice versa. The number of rain, the volume of rain and the relative humidity. Does that have to do with each other? Is there any relationship between those two, a correlation? Probably, yeah. Rain and humidity, how much water is in the air, how damp it is outside. Those probably deal with each other. Skill at rock climbing and the ability to learn other languages. Any correlation between those two? No. Pretty unlikely. Let's just make sure and go with take a look at what D says. Number of MRI machines and the average wait time for an MRI scan. Obviously, they have a relationship. More machines, less wait time. Less machines, more wait time. So we're looking for C. There is probably no correlation between your ability to climb rocks and learn languages. Which pair of variables are likely to have a negative correlation? So, remember, negative deals with, let's say it was a linear relationship. This would be a positive slope, okay? And negative slope would be going down this way. So we're talking about a negative correlation here. Something going down this way. Okay? So we're going to go through the examples here. Age of the tree and its value of wood. Okay? So let's say age is on the x-axis. Okay? So as the older the tree gets, the value of its wood. Does the value of wood go up or down? Does it go up? So what kind of relationship do we think that's going to be? That's going to be a positive one, it looks like. We're going to go on the assumption that the wood value possibly goes up. There's probably arguments to go against that. But let's take a look at another one. Hours spent exercising and obesity. So, the more you exercise, as this increases, does obesity go up or does it go down? Most likely it's going down. What kind of relationship is that? A negative correlation. So we're probably looking for B. Let's take a look and make sure when we go through the other ones. Cups of coffee drunk and time spent gardening. Is there really any relationship between those? It probably has nothing to do with each other. It doesn't matter how much coffee you drink. Probably doesn't affect how long your time is spent gardening. Okay? And number of restaurants and the number of people working in the service industry. So as we get more restaurants, do we have less people or more people working in the industry? More. So what kind of relationship is that? That's positive. So what was our option? B. Looks like B is our answer. The more time spent exercising, the less your chance of obesity is. All right, so this question here, it's really only between two of them. Which two can we take off right off the bat? A and C. That is not a line of best fit at all. All they've done is gone between the highest and what looks like the lowest point and drawn a positive slope. No way is that a line of best fit. Okay? This one here, again, not even close to what's really going on, so we can take away A and C. Now, B and D. Both of them look like they're heading in this direction. What do we call this one here? That's called an outlier. Now, an outlier is technically involved in the data. Our line of best fit is going to go through these points here, but we cannot neglect the outlier. Include it almost like it is like an average. For this one specifically, imagine this is someone's test scores, okay, throughout the year. They're pretty low, okay? Now think of their average. If they have one really high test score, is their line of best fit going to be below all of the numbers or a little above of what they normally get with that outlier? Okay, so we're going to be using D as the line of best fit because the outlier is technically part of the data. So we want this line of best fit to technically still be affected by it. It's going to be a little above. Again, think of it like test scores. You get 50 on all your tests and then 100 on just one test. Your average is probably like a 55, a little above what you normally get. Okay, so our line of best fit in this question was D. D was the line of best fit. All right, question 6. Okay, question 11. The estimation of data on a scatter plot beyond the largest or smallest, I know it says SALEST, that's supposed to be SMALLEST, sets of data. Anyone know what that's called? Extrapolate data. Is it LATE, I think? To extrapolate data. Okay, that is to, if they've given you a set of data, we'll use the exact graph above, and say I asked you, I want to know what the Y value of something out here is. Our line of best fit maybe looks something like that, so we would assume it'd be a point here, or if I wanted to know at 0 where it was, we would assume it's a point here. That's beyond the largest and smallest sets that we actually have. That's extrapolating data, okay? You're estimating. Yeah, you got to make a proper line of best fit to get a good estimate here. Question B. The estimation of data on a scatter plot between 2 points in the data. So let's say I wanted to find right here. Okay, something right there. That's in the data. I want to guess what my Y value is at this X point. This is to interpolate data. Yeah, right. Yeah, it's in the data. Yeah, so to extrapolate is outside of our data. To interpolate is inside of our data. Those are the two definitions we were looking for. Question number 10. This would be roughly your line of best fit. It may vary a little from here to there, but if you're close to that, I will give you the mark for it. Okay, your very last question says to consider the following data. So you guys were to look out of all of the data here. I'm going to scroll up just a little so you can see it all. This was a bunch of football data I pulled off of like NFL.com. Okay, I gave you guys what looked like possibly 3 or 4 sets of data. You guys had to choose which would give you 2 variable data. Okay, you need to construct a graph that would best represent the comparison between 2 types of variable data given. Okay, our games is not what we were looking for. Okay? Most of these guys played the same amount of games. It wasn't really a variable we were looking for. The variables that had some type of relationship or correlation were your rushes, okay? So the amount of times they got the ball and how far they got with the ball. I wanted to see if there was any correlation to the amount of carries you got and how far you got in the year. So one of them was dependent, one of them was independent. Which is which? Anyone know? That's right. So the rushes are our independent variable, okay? And the distance we got, our yards, was our dependent variable. So what that means in this question, down at the bottom, is I wanted you guys to put the number of rushes on the x-axis. Okay, so this was our x. Number of rushes. And number of yards was to go on your y-axis. When you guys ended up doing this, you got something, from what I remember, it looked like this for the most part. Okay. So what it was is there was a correlation between these. It was linear. You had a line of best that looked something like that, depending on how you drew your graph. Okay. So in order to get the full 5 marks, you needed to use yards and rushes. You needed to put them on the correct axis, and you needed to plot the data relatively accurately. Okay, question C says, for the pair of variables, decide whether you think the variables have any correlation. Explain your reasoning. So any correlation means like any type of relationship. If one goes up, does the other tend to go up? And when one goes down, does the other tend to go down? From what we plotted, I wanted you to just strictly look at the graph. It looked like there was a positive correlation between these two. So it looked like the more times a football player rushed the ball or a running back, looked like the more yards they got. Okay, so it looked like there was a positive correlation. Okay, question D. This one is actually a little different. Correlation and cause and effect are two different things. Okay? For each pair of variables, decide whether there is a cause and effect relationship between these variables. So, the more times I rush the ball, did it cause me to get more yards? Okay? So the more times I rush the ball, did it cause me to get more yards? Does one thing cause the... Okay, question 11, we've given you a chart. Okay? I asked you several questions about this chart. Question A says, suppose you calculate the mean days worked by students in July. Does this involve one variable or two variable data? So you could have gone about calculating the mean. The mean is the average. So this would be the average days worked by students in July. Okay? So days in July, right here, you would add them all up, divide by 1, 2, 3, 4, 5, and that would give you the average. Is there one variable data or two variable data there? One. I'm only dealing with one piece of information, one set of data. So this is one variable data, 1V data. Okay? And the reason being is the only variable involved here are the number of days. The students' names themselves for the number of students isn't a variable. Those are the people working at that place. Those are the names they've been given. The only two columns we deal with are column 1 and days in July. The only variable is the number of days worked in July. Question 2, suppose you want to construct a graph showing the number of days worked each month. Okay? Would this graph display one or two variable data? What type of graph would you construct and why? So again, one or two variable data. We're talking about the number of days worked per month. Am I dealing with one or two variable data? Still just one variable. Okay? There's only one variable being involved here. Okay? The months themselves, June, July, August, okay? Those are still just names of months. They don't depend on anything. Because it's June, well, let's say you're a normal, let's say you're a full-time worker. Because it's June, you don't just necessarily work more or less, or because it's July or because it's August. I do realize those are summer months and we live in Canada, so there could be a little bit of discrepancy there. But they're not variables themselves. It doesn't just necessarily June only comes once in a while, July only comes once in a while. Those are set months, they're going to come and you're going to work on those dates. So these are one variable data, okay? Now what type of graph might you use to represent this? Anyone think? What types of graph can you use to represent? Yeah, we could use a bar graph. There's many options here. What else? One variable data. You guys think of any graphs you could have used? Bar graph. You guys could have made a pie chart. What's that? You could have used a line graph. They're not the best one, but you could have used those. Essentially, anything you can use to represent one variable data, I accept it as that type of graph. If you said a scatter plot graph, that is a graph to represent two variable data. That was not acceptable for this one. There's only one variable involved here. Okay?